Hi, I'm an old guy and I do maths, and I think the answer to this question is yes. It's probably easier than it looks. Now, I think the first thing to grasp is the form in which this cubic, which is what this is written. Some of you will recognize this, or it will look vaguely familiar. Those of you who've dealt with turning point form and quadratics will see echoes of that here. So, what have we got? Well, essentially, we have a cubic written in a form in which the translations and the dilations are fairly obvious. So let's start with the translations. So what happens here is this cubic, because of this -3, is translated 3 points in the positive direction along the x-axis, and because of this 2 here, it is translated 2 units in a positive direction up the y-axis, which means that our point of inflection, possibly the scariest thing to find for some people who come to this for the first time, is actually quite easy to find in this form, and it's here. It's at 3, 2. And this is a positive cubic, which means that it will descend from here, pass through this point of inflection, and head on down this way. So that means that we have to find 2 other points. We have to find the y-intercept and the x-intercept, and I'm doing this in the order in which it is easiest to find things. We've found the point of inflection pretty easy. The next thing we're going to do is we're going to put 0 into this, which means that x will equal 0, and therefore we will find the y-intercept. So if we do that, we get a half into 0 minus 3 cubed plus 2. Okay, 0 minus 3 cubed is -27. -27 divided by 2, a half of that. Now note I'm doing this using the order of operations, so -27 divided by 2 is -13.5 plus 2 is equal to -11.5. So that is our y-intercept. It is down here somewhere, and that is -11.5, and x is equal to 0. So that is the point at which this passes through the y-axis. Now, what we need to do is we need to find where it passes through the x-axis. And what we know is that this thing has this sort of shape. And the point of inflection is here, so it's going to run down and through here, which means that what we're looking for is we're looking for a point between 3 and 0. Somewhere here is where this thing is going to cross the x-axis. So let's go to work on that. Now there's a little bit more involved in this. So what we're going to do is we're going to make y equals 0 in this equation up here. So let's go to work. We're replacing y with 0. So we have 1/2 x minus 3 all cubed plus 2 equals 0. So we're just going to work our way into x. 1/2 x minus 3 all cubed equals 2. The effect of dividing this side, or multiplying this side by a half, means that to get rid of this we have to multiply both sides by 2. This makes this 1, it disappears. This makes this 4. So what happens, oh by the way, that is -2. Did I say -2? I should have. So 1/2 x minus 3 all cubed equals -2. My apologies if I missed that. And so what we wind up with is x minus 3 equals negative 2 times 2 over 1, which is going to be negative 4. That is cubed still. Now, so just to tidy this up, cubed equals negative 4. Okay. We need to find x. In order to get rid of this bracket, we're going to have to take the cube root of both sides. So we're going to wind up with x minus 3 equals the third root of negative 4. Now we can move this 3. So that is going to give us x is equal to the third root of negative 4 plus 3. And what we know is that this is going to be a negative number. The third root of a negative number is negative. The third root of 4 is going to be something less than the square root of 4, but it is still going to be negative. And so we are comfortable with that because we know that that is going to be less than 3 when all of this is added up. And so we'll just place it here and we'll set up our coordinates, which are 3 plus the third root of negative 4, or the third root of negative 4 plus 3, as you wish, 0. And that is that point there. And so this thing comes down and begins to turn and heads off down through the y-intercept. So we have the point of inflection, the x-intercept and the y-intercept. Now there's one more thing that I would like a pupil to show me, and that is that they understand what has happened here. This is a dilation, and so what I would want them to do is to take a value of x, something other than what we have already used, and simply work out that value. So what I'm going to do is I'm going to make x equal 1, in which case we have 1/2 times 1 minus 3 all cubed plus 2. And that's going to give us something around here, I suspect. We're just going to work out this as if it has using a value of 1. What does that come to? Well, 1 minus 3 is negative 2. Negative 2 to the power of 3 is negative 8. 1/2 of that is negative 4. Negative 4 plus 2 is 2. So we have a point 1, negative 2. Just let me check those maths again. Just let me run through those. 1 minus 3 is negative 2. Negative 2 cubed is negative 8. 1/2 of that is negative 4. Negative 4 plus 2 is negative 2. I am shocking around negative numbers, and I apologize. I got it right here. I forgot to put it in there. Anyway, errors and omissions accepted. Thank you very much for watching. I hope you found this useful. What we've managed to do without differentiation or any calculus at all is find out what this thing looks like, find its point of inflection, and some relevant points on it so that we can demonstrate our understanding of how these things are graphed. Again, thanks very much for watching. If you found this useful, please like and subscribe, and I will see you next time. Bye.